Hello, and thank you for joining our webinar on Hydrotrue Softeners. My name is Abby Rogers, and I will be facilitating this webinar. If you have any questions during the presentation, please submit them using the Questions tab in the control bar, and we will respond to them at the end of the presentation. I will now hand this off to Ryan Reimer, Hydrotrue Product Manager for DriSteem.
Good morning and good afternoon, everyone. Like Abby mentioned, I'm Ryan Reimer, for those of you I have not met. Today we are going to be talking about DriSteam's Hydrotrue Softeners and their applications. This is a part one of a three-part series, so please join us for the following ones in the following weeks. So an overview of what we're going to talk about today will include water quality in the general sense, what is the purpose of water treatment, talk a little bit about the mechanical and chemical functions of ion exchange, also known as softeners, talk about applications for softeners, then move into what DriSteam has to offer for our Hydrotrue softeners, and then follow it up with maintenance expectations. So, if we had to make a choice to do something, right, and we want to maintain our equipment, the biggest thing as we talk about heat exchangers in particular is the maintenance aspect to it and the longevity of that equipment. One of the things when we talk about water quality impact, whether we're talking steam boilers or cooling towers, or even at your house, like your hot water tank or dishwashers, etc., these heat exchange elements and items can be fouled with different scales and deposits. And as we talk about that today regarding softening, scale is going to be the biggest portion of this, as the softeners will treat that piece of the water. So in a general sense, as we think humidifiers or other heat exchange equipment, the harder the water or the more potential it has for scaling, the more maintenance is required. So some factors affecting scale formation is really the hardness in the water. And the easiest example I have for people that are new at looking at the water chemistry or even seasoned, a good analogy for me, at least as I think about this, is hardness as you raise the temperature tends to plate out. So usually you'll see scale fall on the hottest surface of any type of heat exchanger where the most heat is being released or exchanged. Thinking the exact opposite, as we talk about solubility, adding sugar to your tea or your coffee is the exact opposite of what happens for scale formation on heat exchange surfaces. So what that environment looks like, it's a combination of things. We're looking at the calcium, so hardness, we're looking at the alkalinity, and it's going to break down and form a scale. Obviously that scale's bad. I don't know how many on the call have had to take a service call where you had to scrape off the scale off of a heat exchanger or chemically remove it. It's definitely not the most fun scenario. And the great news is that it can be preventable, or the risk can be mitigated. So looking at a city water report, this is a good example of what I like to bring up. Everyone thinks, oh, I don't know what's in my water, let me just Google it. So I did just that. I pulled the city water report for Eden Prairie, where DriSteam's located, and this is what comes up. So if you notice on here, there's things like disinfection byproducts, there's the disinfectant itself, which is chlorine, and then there's heavy metals talked about, obviously for your health and safety as a consumer. That's what the government and the regulation requires, these municipal plants to report on. Is this safe for consumers? The thing I like to point out here is you won't notice that there's a hardness value. You won't notice that there's alkalinity or conductivity, things that are typically monitored for a lot of different equipment that takes water, our humidifiers being one of them. So how do you get that info, right? So how you would get that info is there's laboratories throughout the nation that do water testing. And then the other method is on site. there's handheld tests, whether that's the color strips as one, or there's drop tests for another titration. So there's different ways to get the answer. Google is typically not one of them, for at least as we talk about different processes and different equipment. So why is water treatment necessary? We sort of talked about this on the first slide. Well, on the top left photo, we have a perfect example of scale formation. Obviously, that's decreasing the pipe size and can cause other problems. But if it's on your heat exchange surface, you could potentially decrease the efficiency of that unit and not transfer that heat. On the top right, we have a picture depicting corrosion, most likely, with iron or different metals being corroded in that system and being dissolved and causing that color offput. Obviously, that's not something we'd like to see when we open our sink, nor would it be if we opened our humidifier, our steam boiler, etc. In the bottom left, we're depicting corrosion, stress corrosion in particular. If we're not cognizant of, let's say, high chlorides, for example, additional corrosion can occur at the weld, or general corrosion if you have corrosive type conditions. And then on the far right, won't necessarily be covered today, but the other aspect of why we treat water is for the biological perspective. And treatment can really include things beyond a softener, an RO system, a dechlorinator, back to the chlorine added for city disinfection is a way that they control microbiological growth. So with that, the next slide here is, well, why use a softener and RO? Today we're going to talk about the softener piece versus the RO. But the water softeners are essentially changing the calcium and magnesium ions for sodium. And the picture on the top is showing sodium carbonate. That solubility is greater than calcium carbonate to be formed, but also the reason we prefer that, at least, is it forms a powdery precipitant versus like a sticky one that will stick to the heat exchange surface. Typically goes out with drain, really depends on the device and what else you're doing. So if we talk about applications outside of humidifiers, like steam boilers, for example, they might do a couple different methods of treatment. One of them most commonly is softeners in commercial buildings. So if they're doing softeners, they're also doing other chemical treatments to maintain different solubilities and protect that piece of equipment. So a little bit more into the softeners and what their purpose is. I know this slide has a lot of different words that you would not see in a day-to-day perspective, but really the main high-level function is you want to exchange with this resin bead, you want to exchange that hardness for a sodium. That preferred sodium obviously will provide maintenance, less maintenance on the downstream equipment when properly maintained. What it is a physical bead that has some reaction sites on it that allow this to do this. So there's the mechanical and the chemistry function. So again, why to do this? Hardness and other cations can form scale, causing more maintenance on humidifiers, other heat exchange equipment, process equipment, and RO systems. This scale, again, more maintenance and premature replacement potentially of that piece of equipment. So a little into the chemistry. Essentially, this is showing at your top level, your raw water, which we're going to call hard water in this picture, is coming in, and it's going to make contact with the ion exchange resin, which is an orangish red color, and it's going to exchange those white sodiums for the green calcium and magnesium. As it flows down through the softener, it's had proper contact time, proper reaction time, and it leaves the softener as soft water. And then to reverse that reaction, since there's X amount of capacity, which we'll kind of talk about on the design side of softeners, is you need to regenerate that. It has X amount of capacity. So It's simply regenerated with a sodium chloride salt. I know a lot of different places sell this. Some of you might have softeners in your house. You know, like a Home Depot or a chemical company would sell sodium chloride. The one note to this is if you do have a sodium sensitive system, there's other types of regenerant, like potassium chloride, for example. But the good thing to note is it's a one-to-one exchange. We're not just strictly taking out calcium and magnesium and everything else on the front end stays the same. We're adding that sodium back in. So a couple pictures. On the far right is a zoomed in photo of resin for those that have not seen it. I always say it kind of looks like fish eggs to me, as I prefer to eat sushi. So it's kind of that color and size. On the left side, we have iron fouled. So one of the things that can decrease the lifespan of that resin is iron. Essentially really likes that resin bead from a chemistry perspective and doesn't want to release when you put salt back into the system. So a little bit beyond the chemistry side, and we didn't go too far in depth about all the reactions and the kinetics of softening, but onto the mechanical function. What's the physical piece of equipment and how does it go through its different steps, mechanically speaking? So while it's in service, hard water comes in and soft water goes out. Pretty simple. It's essentially a dumb device based on the capacity given. And then where the smarts come in and say, oh, I need a backwash, I've gone through my capacity, or if you set it up based on time, then you would have this backwash occur. And what that backwash is going to do is going to lift that bed and make sure it's not compacted. So when you do put that salt brine solution through the system, that it contacts all those resin beads. The one note is you don't want to have too much backwash, otherwise if you see resin into your drain system, you had too much of a force lifting that bed up and out of the system. The next step is the brine draw. So these systems, and I'm going to show a picture on the next few slides of what these systems look like and what DriSteem has to offer. We have a polyethylene brine tank. It's a black tank with an open top. And that's where the salt goes in, and also water. And you're going to create a brine solution. I know we're close to Thanksgiving, so very similar when you brine a turkey, that's essentially what you're doing. You're getting your salt to dissolve up to saturation, and then you're going to draw it into your system. And how that's drawn into the system is essentially a Venturi effect. As you drive one side of the water pressure across it, it's going to suck it and pull it up. Go through that resin bead and reverse that reaction. The last two steps of this regeneration process are essentially rinsing out that salt water, right? If it's salt water, you got that chloride aspect that you definitely don't want to translate downstream. And most processes that you're protecting don't want additional dissolved solids anyway. I guess the one note is after fast rinse, if it's a single tank softener, it'll go back into the service mode. And if it is a twin tank system, the system would go into a standby waiting for that first tank to go into regen. So kind of some applications, where are we seeing these systems? What are the typical uses? I know I mentioned a couple of these. And again, there's multiple things that are being done on these different systems to maintain the longevity of the system, and the softeners play a part of doing that. So for example, the top left picture is a cooling tower, where you see that bracing on the bottom left of that, there's actually plastic fill that is the heat exchange surface for the evaporation to occur. If you see that completely white, you probably had scale occur on that system. So one thing you can do along with chemical treatment is soften that system. And I'm not going to go into what different strategies you're going to have from like a cycles of concentration on all these systems, but that's one aspect of it. On the bottom left is our GTS-LX humidifier representing humidification applications, where softening really can increase the span between cleaning or, and extending the lifespan of that equipment. In the center of the screen, a depiction of a steam boiler. Again, this is an industry that has accepted softening for the most part on steam boilers, on the pre-treatment water, essentially maximizing their fuel usage by not having scale increases their energy use and their operating cost. On the top left, we have a DriSteem RO system, which will be part 3 of our webinar series. What the softener does upstream of that is essentially prevents the membranes from scaling with calcium carbonate. So what that means for you, or for another RO system, is increase the time between cartridge cleaning, or CIP also known as, and also extend the lifespan and the quality of the water that's coming out of that system. And in the bottom right, another picture of a commercial dishwasher. Just like at your house where you might have a dishwasher, you could see calcium carbonate build up. Again, longevity and maintenance. So moving on beyond applications, and I didn't cover them all. Obviously, different places use them for different things. I try to hit on the biggest ones. Things to know though. So some things, time between regen. The typical thing that, at least at DriSteem, we try to size our systems for is 1 regeneration per day. Now, there's some places that might have really high hardness and low usage, so you might not want to use a huge tank from a capital perspective. The one thing to note is when you're putting the pelletized salt in, it does take time for it to dissolve. So you need that to occur. Typically, that's about 6 to 8 hours at room temp water. The next thing that we're looking at is what's our flow rate across the softener bed. We want to make sure that obviously we're not oversizing the system so much that we cause negative effects of channeling. Essentially, a preferential flow occurs and it's not contacting all that available capacity. And the other end of the spectrum is you're pushing it so hard that you're essentially compacting that resin bed and causing a larger pressure loss. So a lot of situations where we're looking at city water pressure, if the plant's not boosting it or the facility's not boosting their city supply, we're looking at 40 to 50 PSI coming in. Well, obviously we don't have a lot to work with if we need to distribute that through the plant. So we want to minimize the essential pressure loss through the system. The other thing is the brine tank should have, and it's an industry standard, this is not DriSteem specific, 4 regenerations of salt storage. I'm guessing most people at these plants don't want to go fill their brine tank with salt once a day. So that's how it typically turns out to be. Once or twice a week, you walk by, you fill up the brine tank, you move on with life. The other 2 things I kind of briefly touched on how long it takes for the salt to dissolve. Pelletized salt, which is the most common, is longer to dissolve than powderized salt, and same with water temperature. The hotter the water, the easier it dissolves. And everyone at least asks me, well, what kind of salt? There's multiple kinds of salt out there. My answer is, at least in perspective of what's the highest purity of salt you can buy based on your operating budget. There's obviously higher purities that have less dirt and debris in it, which equates to cleaning out the brine tank. And that's kind of really the decision maker for the end user, if there's any end users on the call. So the DriSteem Hydrotrue Offering. We have 2 different ways of looking at this. The first way is single tank systems. These are great systems from an economics perspective of systems that don't need soft water all the time. And the question is, well, how do I know if I need soft water all the time? It's essentially based on your desired for your water treatment. And if your application is not 24/7 and you have time at the middle of the night to regen this thing, that might be a great application for you. If you do need constant soft water, A duplex system is the next. So for example, our high pressure atomization systems require constant soft water to then feed an RO and to go downstream to the high pressure pump. Or when uptime is critical, if you can't tolerate any hardness, you're going to want to look at a duplex system. The initial investment is slightly greater with that, but then it gives you that peace of mind to not have hardness at any given time. One of the things from the industry perspective that you will look at is a grain capacity. So this is talking about the exchange capacity. And then lastly, for non-humidification applications, so steam boilers, cooling towers, car washes, indoor agriculture, etc., we're looking in different units. We're talking about gallons per minute to your system. So anywhere from half a gallon per minute, which would be our 7-inch tank, all the way up to 100 gallons a minute, which is going to be our largest 30-inch tank system. And then on the other end, we have a correct process for things that aren't our everyday, day-to-day sold items to capture different systems and different requirements. Triplex systems we have worked with before, so essentially multiple tanks can handle the flow rate in parallel, but one tank's required if you have a low flow situation. Again, these are sized to water conditions using capacity and the flow rate. So a little bit about the offering, and I want to leave a few minutes for questions. If you guys have any, please fill those in as we go through this. But the Hydrotrue offering on the bottom left is our brine tank and our brine valve, followed by the right side of our control valve. That's essentially the brains of the system. That's going to be where all your programming is done, where your regen settings are, your capacity settings are, etc. Followed by the resin again, another picture of that. And then on the top row, your FRP tank, your storage vessel. This is essentially the body holding everything together. And inside that is the distributor tube to then direct the difference between hard water and clean water. And on the far right, support gravel. So this depiction is, one system. So the dechlorinator is going to be talked about in our second series, but right in the middle of the screen is our water softener system. That's very typical from an isolation valve and plumbing perspective. So talking a little bit about Hydrotrue skid mounting, this is an option for our softeners and dechlorinators when they're put together in particular. What this offers to the marketplace is ease of install. You're going to have one electrical drop that's going to go to an outlet box, and then you're going to have one connection for inlet, outlet, and drain. This should reduce installation issues as all that internal plumbing will be done. You just have to make those external connections. So some softener maintenance, it's a trade-off. Using a softener when you didn't have one before doesn't mean you have no maintenance altogether and you can turn a blind eye. There's some things that are typically easier than cleaning off scale chemically or mechanically. So loading salt in the brine tank, definitely a labor of love, that's for sure. Water testing ideally, you want to know if your system's working appropriately. I see John just asked, what's the life expectancy of resin? The life expectancy of resin is 5 to 10 years, and it depends. So obviously, do you maintain your system? Does it run all the time? Is there iron fouling it? Is chlorine breaking the system down from a physical perspective? But generally 5 to 10 years is what I would expect. And it's removed via a vacuum system, whether it's a vacuum truck or a wet vac that can handle the solids. So you can replace that system. There's no drain on the bottom or pulling that out. Other routine maintenance could be seals on the control valve. Check once per year. As you run higher pressures and as you run different scenarios, those seals can break down, but you want to make sure that you have hardness, and that's the easiest way to check is make sure you don't have hardness going through on your soft water side. information for sizing real quick. I'm going to just leave this on the screen. I'm not going to read through this, but essentially we need to figure out capacity and flow rates. And the next step is to contact your local representative today. If you are a rep out there on this call, please give us a call with any other questions you may have, and we'll help you there. And we'll finish the last 5 minutes up if there's any additional questions.
All right, Ryan, looks like there's no other questions coming in. So mind if I wrap this up? Oh, 1 second. Should salt level be above or below the water line?
So the salt level typically in a tank, you want to have some salt in there, because if you see that there's no salt and it's all dissolves, that means you're probably not at saturation. So really the answer can be both, but what we typically see is 2/3 of the brine tank being filled from a regeneration perspective, and your water level is not going to get above that. So you have some capacity to get in between there. It's not like you have to keep it above the water line at all times. Otherwise, you're going to be running into problems. You just want to make sure it gets to saturation.
All right, it looks like that is it for questions. Thank you everybody for attending our webinar on Hydrotrue Softeners. You will receive an email within the next couple of hours, including a recording of the webinar and a short follow-up survey. Please take 2 minutes to complete the survey, as we really appreciate your feedback. And if you have any questions, just please email marketingmail@DriSteem.com. Otherwise, follow one of our social media pages, and I hope you have a great rest of your day. Thank you, Ryan.
Thank you all.